What is a supernova? Soon you might get the chance to see one for yourself on the night sky. Orion's right shoulder used to be illuminated by one of the brightest stars in the sky, Betelgeuse. But in a matter of a few months, Betelgeuse have dimmed. It seems that the red giant star is facing the end of its life. Betelgeuse may soon become the first supernova since 1604 we can see with the naked eye. But what is a supernova? Betelgeuse, like any other star, is governed by two major forces. The force of gravity is pulling the star toward the center, and the force of the fusion processes is acting from the center and out. When gravity is the strongest force, the star contracts, and the temperature inside rises. This causes the star to expand, and thus the star size remains constant. A fusion process demands large amount of energy to happen. But inside the star there is vast amounts of energy. Thermal energy. When the energy is high enough, lighter elements will fuse into heavier elements. This process is called fusion, and when it happens, the fusion will release more energy than it uses. That's how a star can shine for billions of years. When the thermal energy inside a star becomes even higher, heavier elements can fuse. But that only happens in very large stars. Betelgeuse is a very large star. Here's Betelgeuse compared to our solar system. If Betelgeuse was placed where our Sun is, the surface would engulf the orbit of Mars. It only weighs about 20 times the mass of the Sun. Betelgeuse is large, but must have an extremely low density. So low that it's often referred to as a glowing vacuum. In large stars like Betelgeuse, the interior is layered with the lightest element, hydrogen, at the surface, then helium, carbon, neon, oxygen, silicon, and at the center, iron. In the last days of a star's life, silicon will fuse into iron at the star's core. This causes the fusion process to stop. Fusion of iron is not a process that releases more energy than it requires. When iron is formed, the force of gravity will become the strongest and pull the core together. The pressure and temperature in the core will skyrocket. In the last seconds before the star's collapse, the core is so dense and heavy that only massless particles can escape. Protons and electrons are forced together to form a proto-neutron star. From there, the massless subatomic particles called neutrinos are carrying all the energy from the collapse. The flow of neutrinos causes the outer layer of the stars to be ejected into space in an enormous explosion. The light from the explosion will here on Earth be equivalent to the light from the full moon, and even be visible during the day. But if it happens, because we don't know yet if Betelgeuse have started to fuse the heavier elements. The process happens in the core, which we can't see from Earth. The decrease in luminosity can be caused by many things, and Betelgeuse have been a variable star ever since our observation of it began. However, every calculation points in the direction of Betelgeuse as a star that soon will have spent all of its fuel. So within a period of the next 100,000 years, Betelgeuse will have vanished from the night sky in a gigantic explosion. Maybe, in our lifetime, we will bear witness to an astronomical event that could last be seen with the naked eye in 1604.